How do you learn geometry nodes? First of all, by playing with them, and second of all, by watching tutorials. I made a 5.5-hour course thing. The first hour or so is going to be free to you, so let's begin. Hello everybody, and welcome to Introduction to Geometry Nodes, the course that takes you from not knowing geometry nodes to knowing it very well. I'm not going to assume you know anything from the get-go, which is probably what you want, and I'm not a fan of wasting your time, so quick description. My name is Tom. You might know me as CG Matter or Default Cube. These are tutorial channels where I've been teaching geometry nodes for years. All the clips you're about to see, I worked at Mayor Studios doing just geometry nodes. Some effects, some snow, some particle stuff, and that is the extent of it. And every single bit of freelance I've ever gone has involved geometry nodes. It is the most powerful tool in Blender, and it's only getting more powerful, so it is essential that you know how to use it. Literally, the only two prerequisites I would like you to have before starting this course is one, I'm going to be using Blender 4.5, as you can see in the corner here. This is the latest version as of recording, and geometry nodes tends to have a kind of a history or a trend of adding features and pretty much never taking any away. So I expect this course to be valid and up to date in a sense for a long time. If you use a older version of Blender like 4.4 or 4.3, there's a slight chance you're missing a node or a feature that I'm going to talk about. So use 4.5 if you're watching now, use 4 point whatever or 5 point whatever if you're watching in the future. It's still going to be applicable. The only other prerequisite I would like you to have is ideally you watch this course on a desktop computer. This doesn't just let you follow along, but what I really mean is it has a big screen. I want you to watch this on a big screen, not a phone, because it makes it easier to see what I'm doing, because nodes tend to be kind of small unless we really zoom in, which sometimes we'll do, and I can add more and more nodes, and the more that I add, in a sense, the more I have to zoom out. So I would highly recommend watching on a big screen. You could throw it on your living room or just follow along on your computer. I guess let's just get into it with chapter 1 coming up. Okay, we've officially begun with chapter 1. This is about the very, very basics. How do you even interact with geometry nodes? What are they? Why are they even called geometry nodes? And by the end of this chapter, you're not only going to know how to navigate around, which is great, but we're also going to make a project where we make a three-dimensional fractal of an arbitrary resolution. This thing you're seeing is a variant, or it's called the Menger sponge, and this is the kind of thing that's perfect for geometry nodes because it has like so much detail and it would be a pain to model by hand. So let's begin by setting up GeoNodes itself. So I'm in Blender here, obviously, and the first thing you need to know is how do I navigate to geometry nodes? At the very top where you have all your workspaces, by default you're going to have something called geometry nodes, which when we click it, it has all the editors that we need. If you do not have this, you can click this plus icon, which lets you add a workspace, and under general, you have geometry nodes, which I don't need a second one, so I'm just going to delete it. So from wherever you are, no matter how lost in the woods you are, you can just go to geometry nodes. This is composed of primarily 3 workspaces that we really care about. The first one is obviously the 3D viewport. This is helpful to see what it is we're making. The second one is the one we're going to be interacting with the most and is the newest to you. This is the node editor, where we do all of our geometry nodes. We basically draw out our code or blueprints or whatever you want to call it inside of here, which is represented again in the 3D viewport. So you can think of this as input, what we're making, output in the viewer, what we're seeing. And then right here, we have another new editor. It's called the spreadsheet editor. You could think of this as a companion or intermediary editor. Really, it's more so of a viewer where we can see all kinds of data about what it is we're making. And this is useful because when we're juggling around data, adding attributes, it can be confusing, and it's nice to see what's going on here. So for example, here I have the position of, you can see it's 8 vertices. Coincidentally, well, not coincidentally, the cube has 8 vertices, and when I move one around, you're going to see this updates. If I scale them all up, they all update. So this is a live viewer of what is going on, essentially. Alternatively, you can also make your own workspace. If I go to the editor types, you can see we have the geometry nodes editor. We also have the spreadsheet, and obviously we have the viewport. So set this up however you want. I could do a GeoNodes editor, which I can throw on the bottom and make this the 3D viewport. And I can also, like for example, replace the outliner with this spreadsheet. To start off with, I'm going to use the basic layout, but once we get a bit more comfortable and involved in whatever, I do have this custom workspace that is designed to make things more legible. We have our big node editor and our big viewport, and it might just be easier for you to see what's going on. Note that geometry nodes, whatever it is we do, so I'm just going to throw some random nodes on, you're going to see it follows a left to right workflow. So for example, I start with this node, I move to this one, I move to this one, I move to this one. This progresses from left to right, which is unlike some other software that goes top to bottom. This is important because it explains why this area is so horizontal. I want you to see as much as possible. The only other thing you need to know to get started is there is a add-on that is very, very useful. I would even say it's mandatory for you to be using for this, and it actually comes bundled in Blender. Go to Edit, go to Preferences, go to Add-ons, and I need you to make sure that if you type in Node Wrangler, which again you're going to have by default, this needs to be enabled. It adds so many hotkeys, like let me show you the hotkey list. It adds so many that we actually end up using, right? This isn't just a list of things we could. We are going to use these. So make sure this is enabled or the hotkeys I talk about will not show up. And then I guess just as a quality of life thing, if your node editor looks different from mine, specifically you're going to see that my links, the things that connect nodes, are going to be perfectly straight. And if I reroute, these are all going to be straight. This is something that isn't there by default, but you can control by going to the themes. This is saying what is your Blender going to look like. And if I go to the general node editor, which applies to geonodes, shader nodes, compositing nodes, any kind of nodes, you're going to see that we can edit all of these, right? So I can go to my node backdrop and change the color. But most importantly, if I go to the bottom here, you're going to see noodle curving. This is what's going to let you curve or uncurve your noodles. There's reasons to do either. The straight lines keep things more organized, whereas these kind of curvy connections can also make things more organized, where instead of needing to reroute, sometimes it keeps this nice and flowy in a sense. So this is completely up to you what you want to do. Just know that I personally am a fan of no noodle curving, and for the grid levels, which is these dots that you might be seeing, I like to keep that off. So now you know how to get to geometry nodes from any workspace. You know how to make a custom workspace with all your editors, with your spreadsheets and whatever, and you've enabled the Node Wrangler add-on. You are literally ready to begin learning GeoNodes once you've done these. So let's move onwards. The floodgates are open and we can start learning how to actually use GeoNodes now. I think a good place to start, now that we're set up, is talking about what are geometry nodes. Why is it called geometry? Why is it called nodes? Why is this better than manual editing and modeling like you've been used to? Let's talk about that. So if I go to geometry nodes workspace like we've been talking about, you're going to see that by default we get this node editor with a name called geometry nodes. And additionally, and this is super important, you're going to see we have a modifier right here. If I expand this, you can see this is also called geometry nodes. So this is going to give you a bit of a hint as to what's going on here. If I get rid of this modifier, there's no more nodes. What this might indicate or hint at is that geometry nodes, anything that we do here, so I'm just gonna like move this, you don't need to know what I'm doing yet. So here I've made a node network that just moves something. This is a modifier, right? So in other words, if I get rid of the modifier, it's as if nothing happened. If I hide and unhide, you can see it's enabling and disabling our behavior. And if I now rename this to like moving, because that's what this is doing, this renames our node group inside of the modifier, which can also have a name. Like I can call it modifier, ideally I spell it correctly. So this gets to the core of what geometry nodes is. Geometry nodes is a custom modifier. That is what we're doing here. We're building our own modifiers that we can stack on top of each other. Unlike the normal modifier list, which you can see is very limited. Okay, limited bit is a bit extreme. It has array, it has bevel, it has all of these kinds of things, but they're limited. There's something like 30 of them. What geometry nodes lets you do is make any kind of modifier that you can think of as long as you can figure out how to make it. So for example, this is our moving modifier. So let's just shift this over here. I'm actually going to rename this to modifier 1, and then after this, I'm going to add another geometry nodes modifier. This one's separate from the original. I'm going to call this modifier 2. That happens after the fact. I'm going to add a node group. So right now you can see there's nothing here, and the only option we have is our original node group. I'm going to add a new one, which by default is going to be called geometry nodes. So I'm going to call this, well, it depends what I want to do. Let's just say I want to do an extrusion. So I'm going to call this extrude. And then for that modifier, I'm just going to, again, add a random node. You don't need to know these specifics. I'm going to add a extrude mesh node, which what that does is it makes a nice extrusion. And if I now disable the first modifier, you can see it no longer moves, but it does extrude because we've disabled our moving. So we have one after another. If I go to modifier 2, I can actually change which node group it's using. If I change it to moving, now our modifier just moves things, and now it extrudes things. If I enable this, it moves and then extrudes. And the ordering does indeed matter some of the time. So if I flip these, right now nothing's going to happen because moving an object and then extruding it is the same thing as extruding it, changing the shape, and then moving it. We call that commutative. It goes either way. But instead, let's say that we started off with our extrusion, and then for the second one, I'm just going to rename this like scaling or something. For this one, I'm going to change what it does, and I'm going to use some random nodes. I'm going to use something called split edges, and then I'm going to do something called scale elements. And as I bring this down, you can see it kind of separates our thing. By this logic, we start off with an extrusion. We go to modifier 2, which does the scaling. Whereas if I was to flip these, you can see it actually looks a bit different. Why is this the case? Well, when we do our scaling first, it just takes our cube and it does this weird operation that we don't know what it is, but it kind of scales these, and then it extrudes that. Instead of taking our cube and extruding it, which creates this, and then we do our scaling. So we're creating our own modifiers, and the order, at least in this case, does matter. Now, just like any other modifier, the normal behaviors apply. In fact, if I go to our modifier, I'm going to flip the order here, and I go to apply, or you can just hit Control A, and I'll do that again. Now our modifiers have been applied, and this is now actual geometry. It wasn't like a modifier where we still had our original geometry, but we're just creating a visual effect. No, this is actual geometry we can work with. If instead I only applied the scaling, if I go to wireframe and then go to edit mode, you can see we have our cube, but the faces have been separated. So that has been applied, and then we do our procedural, and I'll talk about what that means soon, our procedural extrusion. One other thing that I think is worth mentioning is if I get rid of both these modifiers, or at least hide them, you're going to see our spreadsheet viewer, which we don't know much about, but we can tell, okay, this has 8 vertices that I can move around. This has 8 vertices. Okay, duh. But if I now enable our scale modifier, which now has way more vertices, right? It's composed of 6 faces, where this top face has 4 vertices, this one has 4 vertices. We end up with 6 faces times 4. Excuse my horrible handwriting here. We end up, in this case, with 24 vertices instead of 8. And indeed, if I look over here, we have now 24 vertices. If I have a cube, we go back down to 8, 24, 8, 24. I'm going to enable extrusion, and now we have even more vertices. So the spreadsheet editor also dynamically responds to our geometry nodes, which again is just a word for a custom modifier. It's called geometry nodes because, first of all, it's modifying our geometry, right? It's visually changing, and the spreadsheet says there's more vertices and edges and faces. It's changing our geometry geometry, and we're doing that by, stringing together a bunch of nodes that happen to do certain things. Okay, so geometry nodes, a way to change geometry via nodes. It's silly, but it's good to know. We're just making modifiers at the end of the day. And of course, the name of the game now is how do we make useful modifiers? How do we use these geometry nodes to build things that would have been impossible with vanilla Blender with the vanilla modifiers? And that is what this course is about. So I think I've set the scene. Let's actually learn some of the nodes because there are many, and create something that I don't know if it's useful, but it wouldn't have really been possible in vanilla Blender, at least not easily. So let's get to that. So as promised, our first modifier created with geometry nodes is going to be this fractal looking thing. What you're seeing right now is a variation on something called the Menger sponge, which is kind of like a cube composed of cubes, and there's these like infinite amount of holes inside of them. We're going to make this variant that can also be used to make other things, and we'll get to that. So this is a pretty extreme first node group, and it turns out it's only going to use 3 nodes. Plus the input and output. We're going to learn about the cube node, we're going to learn about the transform node, and we're going to learn about the join node. And it turns out that those 3 things allows us to make this. So here I'm in my geometry nodes workspace, and you can see that this cube over here does not have any modifiers, which means it doesn't have any geo nodes. You can either add it by, going to geometry nodes and picking a node group, or a bit of a shortcut is you just click this new over here, which will inherently know to add a modifier. I'm going to call this fractal because that's what we're making, and I can call the modifier fractal as well. Because we're only going to use the 3 editors of 3D viewport, spreadsheet, and geonodes editor, I can actually hide or get rid of the rest. So I'm just going to move my workspace here and just kind of compress these down so that we don't have all the stuff we don't need. I don't even need a timeline really. And because my face over here tends to hide the spreadsheet, a cool little trick is if you hold down Control and then drag between 2 areas, you're going to get this like icon thing, which means switch. So now I have switched the spreadsheet and the 3D viewport, and we can see everything. I like it. And now, my friends, we are going to begin. So you can see by default, every single time we've had these 2 nodes that I have not addressed. Specifically, we have something called a group input node that is feeding into, it has this link to a group output node. I think you can guess the relationship between these. The group input brings in some geometry and it sends it to the group output, which displays it. In this case, there's really nothing going on because it takes our cube as the input and it says then output it. But if I was to take this connection and sever it, now all of the sudden we have nothing in our 3D viewport because our cube is stored in here. This stores whatever geometry we start with, and this group output has nothing going to it. So I can just reconnect it like this, and that's great. In fact, if I was to change this geometry, so I'm just going to make it a sphere, in this case, it's taking the sphere and this group input, and then it is outputting it. Now, one interesting thing is we don't actually need this group input. I'm going to get rid of it. You're going to notice if I go into edit mode, we still have our sphere, but nothing is being displayed because nothing is being outputted. That's kind of an interesting idea. If I add a new node, so this is our first node, a cube node, which you can see is a mesh primitive. So I'm going to add a cube node over here and I connect it. We are now seeing a cube, which is kind of strange because remember, our geometry is a sphere, but that gets completely ignored because we have this cube node. That is what is being outputted. If I was to, for example, add, and we're not going to use this yet, but like a cone node, which is just a different kind of primitive, and I'm going to bring down our group output. If I was to just kind of switch between these back and forth, you can see again, our original geometry is a sphere, but it doesn't care about that. So we're going to output a cube, we're going to output a cone, and something that's very neat about this idea is if I connect my cube node, you can see it doesn't just kind of live in isolation. We have all of these parameters, right? I can change the size of the cube, the number of vertices, which you're not going to see. Well, you're going to see it in the spreadsheet editor. You can see that's getting populated it quite quickly. You're not going to see unless I go into wireframe, which can now show you all of this geometry. So this hits on the idea of proceduralism, which is a fancy word for saying we're following a procedure. That is the procedure in proceduralism. In this case, the procedure is we take a cube node and then we send it to the output. That is our recipe. It's that simple. But this concept is pretty powerful in that now I can modify things on the fly and just edit them and do stuff with that. This is different than just adding in a cube normally as a mesh. So you're going to see we have this here. I can scale it like this and then Control R to add loop cuts, which kind of mimics this. But now that we have something like this, let's say with, I don't know what that is, 15 loop cuts or whatever, I can't go back and say, actually make it 7 loop cuts. Like what I'd have to do is kind of like join these together. I've lost the proceduralism because this is a destructive workflow. Every step destroys the previous one. Whereas if I look at my geometry node's procedural counterpart, I can edit this at any time. And if I was to add in another node, so this is the second node we're going to talk about, a transform node. So I'm just going to put this in between here. I can like move it and rotate it and do all kinds of things. So again, the procedure, the recipe is I start off with a cube. That is our primitive. That is going to be fed into a transform geometry that moves it. And that is what is going to be outputted. That is our procedure. But note, anything I do to this, so I'm going to rotate it, I can always go back in time in a sense and then change the geometry, add more vertices or whatever without destroying the previous step, right? If I was to compare these, so we have our cube, which doesn't have our transformation versus the one that does have the transformation, we can always go back and forth. We can switch things. In fact, if I make a second cube over here, and I'm just going to change some of its properties such that it has 2 by 2 by 2 vertices, I can now swap these out back and forth. It will maintain the transform, but with different inputs. This is going to be super useful for the Menger sponge thing we're making in a second, but we can totally stack these ideas. In fact, if I like reset and do a group input, which technically is a node, so we know 5 nodes, not 3 because we have these 2. If I feed the input into the output, you can see we get back our original geometry, which is the sphere or the Suzanne or whatever I want it to be. I can do a transformation. So let's say I just move it to the side and I rotate it, for example. I can do this transformation and anything that exists inside this group input will be transformed. So if I swap this Suzanne geometry to a torus, now you can see the torus is moved, or I can add in an icosphere along with a cube that I position and scale down, and maybe I can add another one. You can see all of these have been moved and rotated, in this case as a single unit. Okay, I think you get the idea. So in this case, I really don't care about the group input because when constructing a Menger sponge, which is a cube made out of cubes, our recipe is basically going to be making a cube or a plane or whatever you want to call it. We're going to divide this into 3 by 3, kind of like a tic-tac-toe game, and I'm going to delete the middle over here. I'm not going to use a group input for this. In fact, I'm going to make it myself. This is going to be as simple as stacking or positioning 8 cubes. So this is 1, 2, 3, 4. This is disgusting. 5, 6, 7, 8. And notice that I'm not filling in 9 here. This is like a blank hole. I'm going to position these 8 things. And then you can think of this as a single quantity, this 3 by 3 with the thing missing, and I'm going to inject that inside of every single one. So this in itself becomes a 3 by 3 with this one missing. And then this cube becomes a 3 by 3 with this missing, and it's just recursive, it repeats. In other words, step 1 is we need to put a bunch of cubes in the correct position. To do this, a sensible place is to start with a cube node like we talked about. As I do this, I'm going to talk about some hotkeys. So right now we've been connecting and disconnecting manually. A shortcut for connecting is hold down Alt and then right click. So you can see I'm holding Alt and right click. It creates this like thing, this like little widget over here. If I drag it on top of the group input, it turns red. I let go, it automatically connects these. So this is called lazy connect. I can just kind of go like that. If I hold down Control, not Alt, but I hold down Control, right click, this will sever. So Alt right click, Control right click, and I think the other one that's useful for now. So again, I'm gonna Control right click to disconnect, Alt right click to connect. Another one that's useful is if we are specifically connecting to the group output. Another hotkey, and I know there's a lot of these, Alt, Shift, and click will let me quickly swap between these and have them go to the output. So instead of Control right click drag and Alt right click drag, I can just Alt Shift click. Okay, fine. So I'm gonna start off with a cube, which is 1 by 1 by 1 meters. If I look at the end panel, you can see the dimensions indeed are 1 by 1 by 1. I want to take this and make a copy that I move over to the side over here and join them together. Okay, that's easy enough. I do a transform node, which we know about. I'm gonna take my cube, and then in my procedure, I'm going to transform it. I'm going to move it. If the cube kind of ends over here, we expect to move this by 1 unit so that this left edge is at the endpoint, if that makes sense. I'm just going to translate by, we don't need to eyeball it. In fact, I can just type in the number 1. And now if I Alt-Shift click, we have our cube, we have our other cube, and I want to join these together, which is the third node I'm going to introduce. By the way, for adding nodes, probably should have said this, but it's Shift-A to add a node. This is the same thing as going to the add menu over here. It's just faster, and I can type in whatever I want. Same thing as like doing Shift-A over here. If I do Shift-A and I look for join geometry, you can see this is another node, but this one looks a bit different. It doesn't have any parameters like these numbers over here, and its like input socket is kind of tall and long, and it's weird. It turns out this is a special kind of node where I can feed in multiple things and kind of join them together. This is different than like the transform geometry where if I connect this, it basically swaps. It only has room for one. So I'm going to take this cube and connect it to the join geometry. I'm also going to join in my transform geometry, Alt-Shift-Click to view it, and now you can see we actually have 2 cubes. This isn't like a cube we stretched and scaled. If I go to the wireframe, you can see it indeed is 2 cubes that can be separate or touching or whatever. I'm going to clean up my node network a little by bringing this transform up top, maybe this one down here, and then we've joined them together. Okay, easy enough. Now what I want to do is I want to join another cube, which is now 2 units from the original. So we moved by 1 unit and then another. I'm going to make another transform geometry, but this time I'm not going to move it by 1 unit. I'm going to move it by 2 units. I take this, I connect it to the join geometry, which now has 3 inputs. And you can see Alt-Shift-Click the original cube, Alt-Shift-Click the moved one, and the double moved one. And I joined these together. Now you might have thought to yourself, why am I moving this by 2 units? I'm just going to get rid of this. Why am I moving it by 2 units when I can take the moved one and then move it again? So this is different than transforming by 2. Instead, I'm transforming by 1 and then repeating it. Well, you could have totally done that, right? So I can take this transform geometry here, Shift-D to duplicate. I'm going to connect this here, and now I've moved it again, and I can connect that there. Visually, it's exactly the same. So I have a cube, I moved it again, and then I joined all of those 3 together. This is all completely fine. In fact, there might be reasons to do one over the other, especially since we're eventually going to make a hole here where a cube doesn't exist. So I don't necessarily want to move these 3 as a single unit each time. We can figure that out as it happens. The key takeaway is I've combined 3 cubes. By the way, you can see as we have more nodes, I kind of have to zoom out to see what's going on. A quick fix for this is you can either take a node and hit H to hide it, just like you can hide and unhide an object, or you can use Control H, which is essentially the same thing, but it compresses it less. It preserves some of the parameters. I'm going to do Control H and just kind of move these closer together, and now we have a nice and readable node group. I then want to make a few more copies, so I'm going to make a copy over here, and let's say we make a copy over here. Well, let's take our original cube, the one in the corner. I'm going to transform geometry geometry, connect that here, and then I'm going to join that as well. But this time, the transform geometry shouldn't be moving on the X, but indeed, it should be moving on the Y by 1 unit. So now we've built this one. Very similarly, we need to make a cube over here, which is 1 unit up and then 2 units to the right. We can do that with a single transform, or we can combine them. In this case, I want to combine them, because why not? So I'm going to add another transform geometry. We have our original cube, the moved one vertically, and then I'm going to connect this one, which I want to move not vertically, but horizontally by 2 units. Join the geometry over here, so you can see the socket basically grows with every single input. And now we've made that Katamari, or probably more well-known, a Tetris piece. Or is Tetris always 4 cubes? I think it is 4, because Tetra means 4. Okay, whatever. Now, the last thing we need to do is we need to add in the top 3, and this is getting really tedious. Like, do I really need to make 3 more transform nodes? Well, no, and I kind of hinted at this earlier. We do have this fully formed row over here with nothing missing. We have 3 cubes, whereas this one has something missing. I can take this whole row as a single unit and push it up, which will duplicate the entire row as one entity. Well, we don't really have the row, right? We have the cube, we have the moved one, and we have the moved one again, but these aren't joined together. Wait a second, let's join them together. So I'm going to get rid of this join geometry node, and instead I'm going to make my own join geometry of just these top 3. Another hotkey is, instead of doing join geometry, connecting that with alt-right click, this, and this, which is fine, you can hold Control, Shift, and right-click drag. So basically it's like Control, Shift, Alt, and a right-click for all these hotkeys. So this is Control, Shift, drag. When I let go, now this makes a join geometry and automatically connects it with the 2 nodes in question. I can now alt right click drag to get the final component, and now we have this row, we have the one up here, and we have the one over here. But because we've joined these, I can move them with a single transform by 2 units vertically. So I'm going to transform the geometry, so you can see orders of operation really matter here. So now I'm moving this as a single quantity and rotating it as a single quantity. I'm going to move this on the y-axis by 2 units. And now you can see kind of the final step starting to form here. We have our initial row, we have our moved row, and we have these 2 pieces that are on the second row. We take all of that and we join it again. But then we're actually done. I'm going to Control Shift right click drag to join these together. You'll get used to these with time. And again, if you kind of get lost over here, you can always Alt Shift click to see what's going on, right? So I have my moved row. I'm going to add in these 2 missing pieces, and then finally we need our bottom row, which, if you remember, is this join geometry before we moved it. Okay, so I'm going to join geometry of the join geometry, and now if I view it, all of that work has resulted in this. If I go to the solid mode, you can see indeed the middle component is missing, which is what we want. Now. Because we did this procedurally, and you might be thinking, we could have just moved cubes, god dang it, what are you doing? Because we did this procedurally, a procedure, we can go back to any point in the recipe and change one of the ingredients. What is he talking about? What does he mean? I'll show you what I mean. This monster node group, everything starts with the cube. If I Control right click drag to cut through all of these connections, all of a sudden we have nothing, because every transform and join and whatever relies on this part of the recipe. What this means is, if I take this cube and now modify it, it will edit everything else, because it's like we took our original geometry, moved it around, and joined it. In fact, and here's another hotkey, sorry, you hold Shift and right-click drag. This will connect all your connections or links in a bundle, because they're all of the same type. They're all outgoing from the cube. So Shift, right click, drag. If I take this cube and I swap it with something like a UV sphere, so here's our cube, here's our UV sphere. I'm just going to make the sphere a bit tinier so that they match. The sphere shouldn't have a radius of 1, but in fact a radius of 0.5, so it's touching the edge of the cube. So radius 0.5. I'm going to take this output and now swap it with a sphere, and you can see we've now swapped what exists there, which again is this this idea of proceduralism. I can put whatever I want in here because really everything here is a recipe for moving and combining things. Now, wait a second. If I made a recipe for moving and combining, why can I not take this cube over here, create this like joining, transforming monstrosity, and then take all of that and move and transform, and then take all of that and move and transform, and it gets recursive? We can, and that is the point. So, do I want to like take this and copy it every single time, every time I want to do a transformation? No. In fact, all of this logic I want to compress to a single node, which we call a group. So you could think of everything we did right here as a big node group called fractal. In fact, and this is getting a bit technical here, if I go to the outliner and look at our, I believe it's our Blender file, you can see everything that makes up this Blender file, the objects, the scenes, whatever. We have a node group called fractal, which is all of this. If I highlight all the relevant nodes except for the cube, because that's going to be our input, I'm going to take all of these and hit Control G. You can see something kind of happened here, like it went in somewhere and it added this node group called node group. Well, if I hit this arrow over here, this is a new button. You can also hit Tab to do the same thing. You can see this created a single node, specifically a node group node, if you want to think about it that way. And if I name it something like the copier, you can see that gets edited in our outliner. So these correspond to our node groups, and here we have a node group inside of a node group, so also very fractal-like. If I select this node group and hit Tab, that's what's going to let me look inside of this. Hit Tab to go out, so in and out. You can almost think of this as we have layers here, and I haven't addressed it yet, but you might have seen this bit of text up here. So now let's interpret that. You can see it starts off with a cube with kind of this object icon. That, if I go back to the outliner normal part, is the cube object. So I can just rename this to object, and you can see it renamed over here. So it starts off with an object that inherits the modifier. If I go to my properties, go to modifier, rename this to like blah, you can see that now changes. So an object has a modifier. That modifier then has a node group inside of it called fractal. So if I rename this to blah number 2, you can see we're in there. And then if I go into this node group with tab, we now have one more layer where blah 2 goes to the copier. So there's a node group inside of here. So you can kind of use this to keep track of what's going on. Okay, we did that. We spent all this time basically making this node group, which again, I can swap out the input. So like a radius 0.5 sphere, it now does that. But now I'm going to take our node group, and there's going to be a little piece missing, but I'm going to take our node group and I'm going to duplicate it over here. You can see now all of the sudden it kind of grew, but not in the way we expected, and make a hole of holes of holes. This is because it did indeed copy this. So M, by the way, stands for mute. It lets us treat this as if like these nodes never existed. So in this case, the cube goes right to the group output. We start off with the cube, we then copy, and we then copy. The issue is between the cube and the copier, you can see it grows. What I mean by this is the cube over here, once I copy it, it becomes 3 times bigger. And if I want to kind of reset it so that that can then be copied, we need to shrink this by a factor of 3. One way you can think of this is after the copier, I'm going to use our good transform node, which again moves things, it rotates. So now we've taken all of these nodes and transformed them all. So we're really working with a recipe here. But instead, I'm going to scale on the X, Y, and Z, specifically not by any number, but it turns out you can actually write math right in here. 1 divided by 3. So I'm going to make it 3 times smaller. And now all of a sudden I look at my cube, I look at my copied cube, and it is now the same size, but you can see now we just have to shift it over just a bit because we scaled by the origin instead of like scaling by the bottom left corner. It's in the wrong position. And you can think of this as a correction we need to make by just translating it negative downwards, right? We need to shift it. So if I look, it's kind of lower to the left. So if I make this dot over here of the bottom left corner, and the one for the cube, the vector, which we're going to be talking about a lot. So for now, the vector or the transformation or the direction we need to move is down and to the left. Well, we can do that. And we could think about how much to do it by. I can kind of also do this visually and not really care about the math. If I take my cube and then our transformed version, I'm going to Control Shift, right click, drag. You're going to remember that's the join geometry. So now I'm viewing both of these, which lets us see the offset over here. I'm now going to move negative on the x and then negative on the y. We don't know what that number is yet, but we know they should be identical. You can actually click X and then drag down to change both of these together. If I hold down Shift, which lets me do more fine control than if I didn't, you can see this looks about right, and coincidentally, not coincidentally, the number is roughly a third. So it turns out these numbers correspond, and in fact, I can type in -1 divided by 3, and then they're going to perfectly overlap. So scaling by a third, making it 3 times smaller, means we just need to move it downwards by a third of a unit. You could think about it, or you could just trust the process, okay? Kind of big picture here. We have the cube, we copied it, and we did the transform that allows these to overlap. And now here's the big reveal. Here's what we care about. If I do the copier, I'm going to unmute this and do it again. Wait a second. Now we have a hole full of holes that, again, we need to transform downwards. Let's do that again. So I'm going to do my copier. I'm going to transform that downwards. And now you're starting to see the big picture. No way you could have modeled this at an arbitrary level of detail by hand. Something you might be thinking is, Tom, what are you doing, right? You had a cube, you copied it, and then you transformed it. So like on every iteration, you need to do like 2 nodes. That's disgusting. 2 nodes? What is this? And it turns out, yeah, that is kind of nonsense. So why don't we get rid of all of this? And instead, we're going to take this transform geometry. I'm going to Control C to copy it. And then instead of X, which severs the pole link, you can do Control X, which will delete it, but kind of be passed through. So X just gets rid of the node and the connection. Control X kind of goes through. I'm going to go into the copier, which has all our logic. Control V to paste in our transform node with the -0.3 and the scale of 0.3 and all this. I'm going to connect this inside of here. So I've edited our node group. And now when I copy this, every single time it's going to handle it for us. So let's just do a lot of these. It's getting to the point where I'd have to zoom in quite a bit to see the smallest unit over here. Let's bring this back to the spreadsheet. If I look at this, we've blown up to 17 million vertices, which makes sense. It's just kind of this exponential growth. We start off with 8 vertices. We do a copier. Now we're at 64. It's 8 times bigger, which makes sense. We added these 8 cubes with the middle one missing, so it's not 9, but it's 8. Then we multiply by 8, and that's going to grow quite rapidly. But with this kind of like procedural, this arbitrary amount of detail. Now here is where it gets super, super cool if this wasn't cool already. I'm going to get rid of one of these, so we're actually only dealing with 2 million vertices, which is a lot, but it's nowhere near as slow. You're going to see these copier nodes that I just stacked one after another. They all have this number 6. What is that 6? That 6 means we have 1, 2, 3, 4, 5, 6 instances of these. And if I copy, now that goes up to 7 and 8 and 9. What it indicates is if I make a change to 1, it will propagate to the others. They're instances. They copy the copier. Any modification I make here will modify everything else. But I thought the logic we had was working. It is. But let's just play around with it. I'm going to open up one of these transform nodes with not H, but Control H to expand it. Instead of a translation of 1, which is correct, but let's say we want to play with it, I'm going to do a translation of like 1 point whatever. And whoa, all of the sudden, we're getting the fractal, but kind of arbitrary. We're editing it on the fly. Now, the observant among you, I'm going to bring this up to kind of a special number. Let's say that number is 2. You might notice, or you might get the impression that there are now triangles here. And in fact, there are, or at least an approximation of a triangle. What we just created here is the Sierpinski gasket. So like the Menger sponge, but for triangles. And it turns out the logic is very similar here. So you can see it's a triangle of triangles of triangles. And we did that by just modifying the logic a little. So now if I move this upwards, let's zoom out a little, we get something like that, which is a whole different kind of fractal. I can also rotate these, and now it looks like we're opening up the Menger sponge. And you get all these kinds of things. So I set this to 90, and now we have this kind of pattern that kind of looks like a snowflake that keeps bending. If I set this to 180, now we get this castle-looking thing. 270, I expect it to be the snowflake thing, but just rotated. I can also rotate on the X, because remember, this is like 3-dimensional. Or I'm going to reset all of these values, and instead, I'm going to look at a different transform geometry. Let's open this one up and see what happens. So I'm going to move it on the X. X. Now it's doing something slightly different. Move it on the Y. Let's rotate on the Z. So now it has more complicated behavior. Something that's interesting is every 90 degrees, it seems to go back to its original shape, like it's unraveling and then re-raveling, which makes sense. If you take a cube and you rotate it by 90 degrees, it's a symmetry. It looks the same. Let's scale up by X to get kind of this stretchy fractal. And then finally, let's go to this transform, which is the one that moved up the row by 2. And now we get this nice separation. It looks like the Cantor set, if you know what that is. I don't know if it literally is. So as we go in, you can kind of see these blocks. So this is a block of 1 and 2. I zoom in, and now we have the mirror image, 1 and 2. And then same thing over here, 3 and 4. I zoom in, and it keeps being a mirror image of itself for however many iterations we want. Here's a cool looking one. We really open this into like that snowflake pattern. Don't really know what's going on, but try doing that with modeling with like no proceduralism. And of course, we can totally stack these transformations. So I'm going to rotate by 45 degrees, and then I'm going to rotate by 45 degrees on the other. And now we have, I don't know. I don't really know what it is, but it's more complicated. It almost looks like we're getting a Star of David somehow. I don't know if you see that. Okay, so I think the last thing I want to talk about is this idea that, again, we have 6 copies of these. Now I have 7, now I have 8, and this number updates. What if I don't want them to be instances of each other? Like, let's say I want this copier to have slightly different logic than the rest of these. Well, what I do is I click this 6 button over here, and you can see all of a sudden it gets a different name, and the other ones are still connected to each other. We have 5 of them. What this means is if I go tab into here, and let's just say I added like a transform node over here that does nothing, it's all 0, 0, 0. I go into any of the other ones, and it's as if I never added it, right? So if I go back to the original, it has it, fine. What this tells you is that now they're kind of separate from each other. If I now go to the transform geometry of our detethered one and I do something to it, you can see it is moving, but like only like a ghost image of it, because we're not kind of copying what it is we're doing every single time, if that makes sense. So let's actually just get rid of that, do this, and now, ladies and gentlemen, let's see if we cannot crash my computer. So remember, all of this, which by the way, I can make a node group as well, a node group of node groups, Control G. So now you can see we're many layers down. We have the object with the blah modifier with the blah node group going into the node group of the node group. So I'm going to go up all the levels. You can see this ultimately boils down to an input of the cube, and then we'll call this like a 6 copier. Now, a cube with only 8 vertices results in 2.1 million vertices. I want to put in something a bit different, and it's going to be dangerous because a UV sphere, even though by itself only has 482 vertices, is going to explode. Like if 8 vertices made 2.1 million, I don't even know. I'm going to take this sphere. Let's do a wireframe view. I'm going to bring down the number of segments. So this is another procedural workflow where I can play with the number of subdivision. Not really. The amount of geometry. I'm going to bring down the radius to 0.5. So it's the same size as the cube like we talked about. And I'm going to connect this and hope for the best. Okay, we're frozen, but it did it. So it's still in the shape of the Menger sponge because again, we're copying, shrinking. But if I zoom in enough, you can see this time it's composed of spheres. So I just want you to get used to this idea of recipes and proceduralisms and how we're just creating a really fancy modifier that I can actually rename to our, how do I spell that? Fractalizer, which the node group that is ultimately the full thing can get the same name. Let's do something a bit interesting and then we'll wrap up. If I go to the 6 copier, I open up one of the copiers that makes it up. What if instead of like all 8, because the middle is missing, we get rid of another cube? Instead of having this like tic-tac-toe grid, this 3x3, where I get rid of the middle, let's also get rid of the top, or I don't know, something. I don't really remember how this goes. I'm just going to delete an arbitrary one. Control, right-click, drag, and now, wow, that was an easy way to get a fractal. Let's get rid of that one. Let's get rid of, I don't know what this is, but let's get rid of it. And you can see we get all these different kinds of things. So now we have like a really detailed line. Oh yeah, this is literally the Cantor set. One thing I just played with is if I take my transform geometry, which is the resetter that again scales it down and moves it, and instead of 1 divided by 3, I make it 1 1 divided by 4, you can see it almost deconnects, it fragments, but it's still kind of the same thing, but now we just zoom in and you can see it's fragments, made of fragments, and it goes all the way down. And then the translation, instead of 1 divided by 3, it's going to be negative 1 divided by 4, and now it's nice and centered. Oh, and by the way, I got rid of this connection over here, and this is like exactly the triangle. I'm going to use a magic number called 0.5, 1 divided by 2, and now we have something that really kind of looks like a Sierpinski gasket, kind of like a modified version of it. You know, you can play with this until the cows do the cow thing, but you get the idea. So just with 3 nodes, if you don't count group input and output, we did the transform, the join, the cube primitive. Just with 3 nodes, we made a fractal that is completely procedural. You can swap it out. You can make animations that you wouldn't have been able to before. So when you think about geometry nodes having hundreds of nodes, I think it definitely has more than 100. I don't know if it has more than 200. The possibilities are stupid in a good way, stupid crazy. And that is a flavor of what this course is about. So do we call that chapter 1? Do we move on to chapter 2? I think so. So join me in chapter 2, where I will tell you what we're doing, but just a bit of a hint, it has something to do with fields, and I'm not talking about grass. And it has to do with parameters, and I am talking about parameters. No pun in there. So yeah. Look at you. You made it to chapter 2. I've seen you grow so much. You were just like this tall, and now you're getting a bit taller, but we're going to get more and more advanced. So the theme of this chapter is going to be time, which I'm going to exhibit through gears and clocks and stuff like that. So we're going to talk about how to incorporate time into geometry nodes, which is great whenever you want anything to move in terms of animation, or you want to calculate something based on your current frame number. I'm going to be introducing a few more nodes in this chapter, because the more nodes you have, the bigger your toolbox is. Specifically and mainly, we're going to be using the scene time node. This can output the number of seconds that have elapsed, or the current frame number, the number of frames that have elapsed. So as I scrub through my timeline, you can expect the seconds and frame quantity, which I made a custom node for. This is just a viewer for tutorial purposes. But you can see as I scrub through the timeline, it will tell me the number of seconds or the exact frame number, which is going to be useful for animation. And then the second biggest node we are going to be talking about is the math node. This is basically your bread and butter in geometry nodes. Anytime you want to convert one number to another, you are going to be using the math node, which I know it's going to be scary. Let's zoom out a little. Look at that. I mean, it has a whole lot of operations, which is a lot until you actually look at the specifics. So we know how to add, subtract, multiply, divide. These are all familiar. You've probably heard of sine, cosine, tangent, powers, square roots, exponents. And then we have some more unfamiliar ones that we're going to be using, specifically this section over here, where we have fraction, truncated modulo, truncate, ceiling, all of that. So expect to get familiar with time and math, and let's get started. So there you go. You've had a taste. If you want to go further and you like my teaching style and you want to finish the course, you can get it. You can buy it, in fact. I'm pretty proud of it. And yeah, decision's up to you. Goodbye.